Hi guys. I'm doing the ICT videos, and I just decided to do a few chapters which are quite tricky, right? Like ICT is quite an easy subject. To be honest, there are some chapters where you can just read and understand. There's not much, but there are some chapters where you might need some help, right? So that's what I'm doing some of those videos on these chapters. Today I decided to do the chapter number 3 in the grade 10 book, data representation methods in the computer system. In that you have number systems, right? And number systems are very tricky for if you don't get it right. But if you get it right, it's the most easiest lesson that there is. And you need that because in your O level paper, you will have conversions and you need to know it properly. If you don't know it properly, you're just losing a few marks. Even if it's a few marks, it's a big thing. And even for A levels, if you're doing local A levels, you have something called General Information Technology, GIT, right? And even there, you will need conversion. And let me be honest with you, the JIT paper is so much more easier than the O level ICT paper. So if you get your O level stuff right, A level JIT is going to be a breeze, right? So that's what I decided to do, number systems. So today we're talking about decimal conversion. So I will give you a brief introduction on the number systems, on the different number systems, and also I will teach you how to do decimal conversion. So here's the video. Enjoy. Okay, so today we're going to learn about data representation in computer systems, right? You know how data is represented in computers in forms of number, right? So different number systems are used for representing data. Well, today we're going to focus on decimal number system, but I will give you all a brief description about the other number systems that you learn. So basically, there are different systems that we will learn. This is a chart of the system, the base number of that system, and the range of that system. You learn binary, octal, hexadecimal, and decimal system. So basically the computer, it uses binary system. These systems also you will learn for your O levels, right? So in binary system, the base number is 2. The range of that system is 0 and 1. In octal, the system, the base number is 8, range is 0 to 7. In hexadecimal system, base number is 16, the range is 0 to 15. In decimal system, base number is 10, range is 0 to 9. Okay, so I'll just give you guys a few moments to go through this. Binary, base is 2, range is 0 and 1. Octal, base is 8, range is 0 to 7. Hexadecimal, base is 16, range is 0 to 15. Decimal, base is 10, range is 0 to 9. Okay. So you all must be wondering how to get the range of that system. You might be confused about what the range is, right? So I got a little trick that I use. So now basically when it's binary, the base is 2. The range is 1 and 0, right? And when it's others, now we did the ranges. So wonder how you get it. Well, I got a little equation for it. Basically to find the range, you have the base number of that system minus 1, you get the final number of the range. So basically base number minus 1, you get the final number of that range. Okay, so when you get the final number of that range, then you know that that number system has 0 to that number. Okay, that number is the final number. So let's test it out, right? Okay, so binary base number is 2. What is, so 2 minus 1 equal to 1. That is the final number of that range, right? So what is the binary range? 0 and 1. So let me go to hexadecimal. 16 minus 1, 15. What is the range? Isn't 15 the final number of that range, right? 0 to 15. Go to octal. 8 minus 1, 7. Decimal, 10 minus 1, 9. What is the range of these? So octal range is 0 to 7. Decimal range is 0 to 9. See? So basically, it is base number minus 1 will give you the final number of that range, and 0 to that final number is the range of that system. Okay. So one thing, now these are just basic idea about the whole number system. One thing that you will be asked, you will be quizzed upon in exams is conversion. Exam questions, you will see this conversion. Whether it be your O-level paper, whether it be your A-level GIT paper, General Information Technology paper, they will always test your conversion knowledge. So basically, you will be told, or you will be asked to convert a number from one system to a number in a different system. Conversion is different from decimal to binary or hexa or octal. You will be asked hexa or octal. You will be asked to convert, and vice versa. One, it will go from binary to hexa, binary to octal, octal to binary, octal to hexa. You will be asked to convert. So how do you do that? Well, for this lesson, I'm going to teach you how to do decimal conversion. This one, I will teach you how to do decimal conversion. It's quite easy. Let's see how. Say you're given the number 16 decimal. You know it's a decimal number because the base number is 10. 16 to the base 10. It means it's a decimal number. We convert it to a binary number. 16 divided by 2. 8 divided by 8. 0 divided by 2. 4 remainder 0. 2. 2 remainder 0. 2. 1 remainder 0. So basically binary number of this is 1 4 zeros. That is the binary version of this number. 16 decimal base number, the binary version is this. Octal version. 16 divided by what number? 8. Base number of octal number system is 8 divided by 8. 2 remainder 0. 8 divided by 2. 0 remainder 2. So what is this? The octal number will be 0208 to the base 8. We'll think about hexadecimal system, no? 16 divided by, what's the base number of hexadecimal? 16. So then it will become 1 remainder 0. So what is going to be the hexadecimal version? 10 to the power 16 will be the hexadecimal version of this number, right? So see, this is the decimal number, right? 16 to the base 10 is a decimal number. When you convert it to binary, it is this number. When you convert it to octal, it is this number. When you convert it to hexadecimal, it is this number, 10 to the base 16. Now just for a recap, it's easier to remember this way. Any decimal conversion, right? Any decimal conversion means from decimal to any number. This is the formula for it. It's just a little trick to remember. Decimal to any number, you divide that decimal number, by the base number of the system. So basically, any decimal conversion, anytime you convert a decimal to any number system, it's easy to just divide the decimal number by the base number of that system, right? So if you're converting to binary, you divide that number from 2's. If you're converting it to octal, you divide the number from 8's. And then if you're converting it to hexadecimal, you divide the number by 16 because those are the base numbers, right? Okay, so how do you convert binary, octal, hexadecimal, all of these three to decimal? Okay, how do you convert all these three number systems to decimal? Well, easy. We'll show you how, right? I'm going to convert a binary number 1 1 0 2 to a decimal number. How will I do this? 1 1 0. You need to put your binary number, base number, to the power of that. So binary base number is 2, no? 2 to the power 0, 2 to the power 1, 2 to the power 2. Now what happens? 2 to the power 0 is 1. 1 into 0 is 0. Plus 2 to the power 1 is 2. 2 into 1 is 2. 2 to the power 2 is 4. 4 into 1 is 4, right? So altogether what's the total? 4, 5, 6. 6. 6 to the base 10 is the decimal. This is decimal version is 6 to the base 10. Now let's convert octal number. Let's convert octal number to a decimal number. 1275 base 8. How do we convert it? 1275. 8 to the power 0. 8 to the power 1. 8 to the power 2. 8 to the power 3. 8 to the power 0 is 1. 1 into 5. I mean, it's easy if you all do it in a book. 1 into 5 is 5. 8 to the power 1 is 8. 8 into 7, okay, 56. 8 to the power 2 is 64. 64 into 2 will be 128 plus, I don't have space, so I will write it down. 8 to the power 3 is 512. 512 into 1 is 512. This is 512. So, altogether how much is the total? Add all of this, it becomes 701. So, 701 to the base 10. This octal number to the decimal number is this, and this is how you do it. Okay, so basically you take that octal number, you split it like this. Each number, for each number you put the base, that is 8, put the base number, make it into powers, then that base number into power into that number up here. So like say 5, you take 8 to the power 0 is 1, 1 into 5 is 5. 8 to the power 1 is 8, 8 into 7 is 56, 8 to the power 2 is 64, 64 into 2 is 128, 8 to the power 3 is 512, 512 into 1 is 512. Then you add all these 512 plus 128 plus 56 plus 5, you get 701 to the base 10. Okay, so now that is octal. How do you do hexadecimal? Hexadecimal, say 329. Okay, so these are all in 16 into the decimal. So let's see how. 3, 2, 9. 16 to the base 0. 16 to the base 1. 16 to the base 2. Now what do we do? 16 to the base 0 is 1. 1 into 9 is 9. 16 to the base 1 is 16. 16 into 2 is 32. 16 to the base 2 is 256 into 3. 256 into 3 is 768. So altogether this total 768 plus 32 plus 9, the total you get 809. So basically to the base 10. 809 to the base 10 will be the decimal number of this. So 329 to the base 16. Decimal number is 809 to the base 10. Basically, any number system to decimal, you will have to first get the number separate and then get it in multiply by power of base into number and then add all the products. What you saw before, you take a number, then you put the base of that system, like say you take 10, you will put 2. So basically you will put 2 to the power 0 to the power 1, and then you will get that product. And wait, let me just show it to you. Like I told you, 1 0, that is into 2. Basically this you will say 2 to the power 0, 2 to the power 1. And what will you do? This is how it is. 2 to the power 0 into 0 plus 2 to the power 1 into 1. So 2 to the power 0 is 1 into 0 plus 2 to the power 1 is 2 into 1. 1 into 0 is 0 plus 2 into 1 is 2. How much is this number? So adding this you get 2. So 1 0 to the base 2 is 2 to the base 10. So basically, that is how all the other number systems. So when it comes to an octal number system, I'll take the number I used, right? 1, 2, 7, 5 to the base 8. So you will do this. So like I said, 8 to the power 0, 8 to the power 1, 8 to the power 2, 8 to the power 3, and it goes like this. 8 to the power 0 into 5 plus 8 to the power 1 into 7 plus 8 to the power 2, 8 to the power 2 into 2 plus 8 to the power 3 into 1. Okay, so basically it goes as 8 to the power 0 is 1 into 5 is 5, 8 to the power 1 is 8 into 7, 8 into 7 will be 56 plus 8 to the power 2 is 64. 64 into 2 will be 128. So 8 into the power 3 will be 512. 512 into 1 is 512. So altogether when you add all of this, it will become 701 to the base 10. Right? So basically even for hexadecimal, it will be the same thing, except that these what we use here, it will change. Now if this was if this instead of base 8, if it was base 16, then all this one what we used here will change to 16 to the power 0, 16 to the power 1, 16 to the power 2, and 16 to the power 3, and likewise the answers will change, right? That is the way that we did this. So just a recap of what we learned is how to convert decimal to any number system, and we learned this is one. The other one is any number system to decimal. So these are the conversions we learned today. There are 3 more systems that we need to learn conversions for: binary, hexadecimal, and octal. But those will be taught in the future lessons, right? So until then, good luck and happy studying. Hope you all got everything. And all these tricks that I showed, those are what I used when I was doing exams. So you could always use them because they are correct. But these are not like officially there, but these are just little tricks that I learned myself, right? So you can use them. And yeah, see you all next time. Happy studying. Thank you.